Ever had your Python code suddenly crash and you had no idea why? Imagine your app is running perfectly fine and then error, zero division error. But what if I told you your code never has to crash again? In this video, we are unlocking one of Python's most powerful survival tool, exception handling. Stick till then because I'll show you a real world trick developers use to debug faster and write code that never dies. Ready? Let's break some code safely. So, what exactly is an exception? Think of it like your code throwing a tantrum when something unexpected happens, like when dividing by zero or opening a file that doesn't exist. Instead of crashing, you can teach your code to say, okay, that did not work, let's handle it. That's where try except finally come into picture. They are your code's do not panic button. Watch this, I'll run a small example and you tell me what happens. Let me give you an example here. Suppose I write A is equal to B. Any guesses what error should it throw? So it gives me a name error. Name B is not defined. Okay, now with try and except, the same code runs without stopping. Let's see that how it works. So we'll see the same. I'll give the same code A is equal to B, but now within try code block. Try and then A is equal to B. So this is the piece of code which is supposed to fail. Okay. Now what I'll do, except, so this except, right, this except block, the above exception will be caught by this except block here. The exception, it means A is equal to B will throw an exception name error. So this will be caught here in the except block. Now let's print here the variable has not been assigned. Okay, so this is a good message for the end user, guys, when compared to the name error. So name error, if a user reads it for the first time, he or she might not be able to properly summarize what the error is. So if we give some user defined message here, so it's user friendly. The variable has not been assigned. Now let's run and see this. The variable has not been assigned. So now it is not failing with name error. Instead, it's giving one message that the variable has not been assigned. Okay. In case I want to have the same error printed instead of any custom defined, so here we had a print statement, right? Instead of this, I want to just print this. So what should I do in that case? Let's see how it works. So I'll do the same. Try A is equal to B and then accept. And here we have a exception handler class which is called name error. So here if you see, right, here we got name error. So this is a exception class. So let's call the same here name error. If you see, it's already prompting me as I'll give an alias as ex. Okay, so this is one type of exception and let me now print ex. So this will print the same error message that we saw above, the name error. So name B is not defined. Okay, now let's see another type of exception. Try result is equal to 1 divided by 0. Okay, now I'll write one except block here within except, sorry. So except block and I'll call another error handler class or exception handling class which is called zero division error. Okay, as ex, and now I'll print ex. So this will exactly print the same message that the class zero division error would return. But along with that, I want to print a user defined message also. Please enter the denominator greater than 0. Okay, let me run this and show you. So if you see this, the first message is from the class itself, division by 0, and this is thrown by the zero division error class. And second one, it's the print statement that we wrote here. Okay. So all these exception handlers, zero division, name error are defined from a main exception class. So let's see what that means, the main exception class. So I'll copy the same example here and I am going to write one more thing here. Suppose I'll do 1 divided by 2 and I'll write A is equal to B. So now if you see this A divided by B, because B is not defined, it is going to throw a name error. So this won't be caught here in the division 0 error. So what we can do is we can define a base or a parent class of exception which can handle any type of exception. So for that, what I'll do, I'll again have the except block here, and I'll call the base class here, which is exception itself. And I'll give another alias as ex1. Let me now print the ex1 message here, and then I'll print another user defined message here. Main exception caught here. Okay. So you can write any number of exceptions, but one thing to remember, you will have to write the parent exception class only at the end. We cannot write this before division error or any kind of exception. Okay, so now let me just execute this and show you the output. So if you see here, this is returning me name B is not defined, main exception caught here. Okay, so let's go ahead and see another example. Okay, let me write a try block here again to start with. I'll declare a variable called num, and I'll take some user inputs here. Input, within this, I'll ask user to enter a number. Okay. Now what I'll do, I'll have a result is equal to 10 divided by the number that user has entered. Okay. So this is the place where exception might rise. If a user enters 0, then it will go into zero division error. Okay. Then what I'll do, I'll write one except block which says value error. So this is another exception handling class. And then I'll print this is not a valid number. Okay. So in case user enters anything other than an integer, like some variable, some string, then this is going to be caught in the value error, saying that this is not a valid number. Okay. Let us write another except block which says zero division error. Okay. And I'll print here enter denominator greater than 0. Okay. Sorry. And after this, let us write the main exception class. Except block, exception class as ex. Okay. So this is to handle all other types of errors. And then let us print the ex here. Okay. So now let us execute and see. We'll give the values one after other. So let me first enter 0 here. So this will give enter 0, enter denominator greater than 0. So it went to the zero division error, this except block, because I gave the input as 0. That's why this message enter denominator greater than 0. Now let me execute it one more time and I'll enter one string here, hello. Okay, so this is saying this is not a valid number. So this is where it went to this except block because I entered a non-integer value. So it went to the value error and it printed me this is not a valid number. So I hope this is clear, guys. Now let's see another example using try except along with else block. So if exception is not happening, I want to close this try block with the desired output displayed. Okay, so let's write the try block here. We'll see that with an example how the else block works with the exception handling. So let me do one thing. I'll just copy the same thing here maybe. Okay, I'll have the same example here to explain the else block. So, in case I return a valid number, suppose I gave input as 5. So let us see, let us execute this and see. This should not return me anything. So it's not returning me anything because it's not going to any of the exception blocks or except blocks, right? So to handle this, we will be having one else block here and we will print, we'll have an f string here. The result is within this I'll print my result here. Okay, so now when I run this, if you see, I'll give the input as 5, so this should return me 10 divided by 5, that so the result is 2. If you see here, it gave me the result as 2 here. Okay, so in case of exception, else block won't be executed if I enter 0 or hello or any other string value. So this will not even come to the else block. It will just go to the except block here. Okay. So whenever an error happens, that would be handled in the except block. If none of the exceptions get raised, then else will be executed. I hope this is clear, guys. Let's see another example using try, except, else, and finally. Okay, so let's go to a new block called finally. We saw try, we saw except block, we saw the use of else block. Now we'll go to another keyword called finally, and we'll see with an example how do we use this finally keyword or the finally block. Okay, so again try, and let's use the same example. I'll just copy the same here. I'll copy the same and we'll see how we can make use of the finally block here. Okay. So as discussed, this else block will only get executed when there is no exception. In case there is an error, it will be handled in one of the exception blocks or except blocks. Okay. So let me just write the finally block here. So the finally block, right, will get executed even if there is an error. Whether or not there is an error, it will get executed. Okay, let's see. I'll just print here execution complete. Okay, so let me just run this and we'll see. First, let me give I'll just enter 0 here so that it will go to the except block, and also it should go to the finally block. Okay, if you see here, it gave me enter denominator greater than 0, but still it went to the finally block. Now let's give a valid number like 5. Even then, right, it will go to the else block in this case, and also it will go to the finally block. Let's say the output. Here you go. The result is 2 and execution complete. So these are some of the ways of handling exception. Here is a cool trick. Imagine you are processing hundreds of user entries. Normally, one bad input can crash your whole program. But with exception handling, you can skip the bad ones and keep going smoothly. So that's the power of try and accept. Your code keeps working no matter what. Let's say you are processing a list of numbers. Some are valid and some are not. Without exception handling, your entire program crashes the moment it hits an invalid input. But with this trick, you can skip the bad ones and keep your program running smoothly. Now let's see an example for the same. So I'll declare a list called numbers here, and I'll pass 10. I'll pass another number as 20. Then maybe let's give us a string here, hello, and then we'll pass 40. Then let's have 50, and then maybe XYZ. Okay. Now I'll run a for loop here for n in numbers. Try result is equal to, I'll convert the numbers to int here, and then I'll say multiply the numbers by 2, and then let me print processed comma result. So I want to print the processed result here, and suppose like to overcome, so this will for sure give some error because I have given input as hello and xyz, which are string and not integer. So while we have this int function which will convert the integers to which will convert the strings to integer, here it will fail. So to handle this error, we'll have the except block here, and let's give the value error class here, and I'll have a print statement with the f string which says skipping invalid values, and we'll pass the invalid values here. So let's execute and see this. If you see here, it was able to process 20, it was able to process 40. So 20 in the sense it was able to process 10. So 10 multiplied by 2, 20. And then it came to 20 here. So 20 multiplied by 2 is 40. So it printed these two. And then when it encountered this hello string or hello keyword here, it said skipping invalid values. Hello. Okay. Then it came to 40. So 40 multiplied by 2, 80. And then 50 multiplied by 2, 100. These two are processed. And again, XYZ, it said skipping invalid values. So now you know Python exception handling isn't just fixing errors. It's about writing fearless professional code. If this video helped you, hit the like button and share it with your buddies and subscribe for more real-world Python wisdom. In my next in my next video, we are diving into Streamlit, the easiest way to build web apps with Python. So if you haven't already, hit the subscribe button and turn on the notifications because the next one is going to be super exciting. Till then, keep coding.